In the world of AI, you've got these giants, right? OpenAI, Google, they've been dominating the ring for a long time. But every once in a while, a new challenger steps up that just completely changes the fight. And we got to dive into this because a new open source model called DeepSeek V3.2 isn't just trying to compete, it is aiming for a knockout. And look, that is not just some flashy marketing slogan. This is a direct quote from the developer community, their reaction when this model dropped. I mean, when you hear claims that an open source model is going toe-to-toe with the next generation of closed models, you have to stop and pay attention. The real question is, how on earth did they pull this off?
All right, let's start by looking at what makes this model a true contender. This isn't just some small incremental update. No, this is a massive leap forward that puts the entire industry on notice. We could be looking at a real shift in the balance of power.
And the resume on this thing is just wow. We're talking gold medals in top-tier math and programming competitions. Its reasoning abilities rival the best in the business, and it's all built on their existing V3 architecture. But maybe most importantly, it's released under a permissive MIT license. That means the keys to this incredible engine are basically being handed to the public. So what is the secret sauce here? How do you get this insane level of performance without just building a bigger, more expensive model? Well, the answer is in a really clever architectural design that lets them build a more efficient and more powerful AI. The core technology is something called Mixture of Experts, or MOE for short. Now, instead of firing up the entire massive model for every single request, an MOE model only uses the specific parts it needs for that particular task. It's all about working smarter, not just harder. Think of it like this. A traditional dense model is like one giant team of generalists trying to solve every single problem at once. It's incredibly powerful, sure, but is hugely inefficient. An MOE model, on the other hand, is like a company with a really smart manager. That manager routes each specific task to a few small teams of specialists. You get the perfect expertise for the job without the massive overhead. And this is a brilliant illustration of how it works under the hood. For every little piece of information, what the system calls a token, that comes in, a part of the model called the router acts as that smart manager. It picks the best few experts for the job, gets their input, and then combines it all to form the final output. It's a really elegant and efficient system.
But, and there's always a but, right? This incredible efficiency comes with a hidden cost. There is a catch. When you try to scale this beautiful system up to serve millions of users, you run headfirst into a massive engineering challenge.
Right, exactly. What is the catch? Because this all sounds way too good to be true. And in a way, it is. The problem isn't the model's design itself, but what happens when that design gets incredibly popular.
See, for a single user making a single request, the system is an absolute dream. It only needs to wake up a tiny fraction of its total brain power to get the job done quickly and cheaply.
And to put a number on it, a single query only activates about 37 billion parameters. Now you can think of parameters as the individual connections in the model's brain. So it's only using a tiny sliver of its total 671 billion connections. It's lean, it's fast, and it's super cost-effective.
The problem starts when you get lots and lots of people using the model at the exact same time. See, each person's request is different, which means each request needs a different set of experts to be activated.
And you can see the problem illustrated perfectly right here. With one user, you need just 8 unique experts. No problem. But handle 32 users at once, and suddenly you need over 100 different experts. By the time you get to 128 simultaneous users, you need almost all of them online at the same time. The number just explodes. And just like that, poof, that amazing efficiency advantage just evaporates. To serve a large batch of users, you have to load nearly the entire 671 billion parameter model into memory. This creates this colossal memory bottleneck that can bring even the most powerful hardware to its knees.
So, how you solve what seems like an impossible hardware problem? Well, you fight fire with an inferno. The solution is a combination of absolutely massive hardware clusters and some very, very clever engineering.
The basic building block for all this is something called a GPU node. The easiest way to think about it is like a supercomputer in a box, just packed with multiple top-of-the-line GPUs, all wired together with incredibly fast connections. Now, this is where things get really interesting and, frankly, a little counterintuitive.
They found that you'd think adding more computers would just add more complexity, more overhead. But with these MOE models, the opposite is true. By connecting more of these GPU nodes together, you actually make each individual node more efficient, which dramatically improves your return on investment. And this is why having cutting-edge hardware is just non-negotiable. This chart shows the performance jump from NVIDIA's H100's GPUs to their newer B200s. You're seeing nearly a 3 times boost in tokens per second per GPU. In simple terms, that's a massive increase in how much information the model can process at once. This leap in performance is what makes serving these giant MOE models economically viable at a huge scale.
Okay, let's pull back from the deep technical details for a second and look at the bigger picture. What does all of this really mean for the future of artificial intelligence, for innovation, and for the entire tech market?
So what's the big takeaway here? It's that the game has fundamentally changed. For the first time, open source models aren't just kind of catching up, they are genuinely competing on performance with the biggest names in the industry. This proves that the future isn't just about who can build the biggest model, but who can build the smartest, most efficient one. That performance gap is closing, and it is closing fast.
This leaves us with one heck of a question. For years, the major tech companies have relied on their massive scale and their closed proprietary models as their biggest advantage. But as these powerful, efficient, and open models like DeepSeek V3.2 enter the arena, that advantage starts to shrink. It really makes you wonder, what's their next move?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.